Hello, good evening, guys. I'm sorry, guys. I guess there's some. Hello, guys. How are you? So, before we start our class, what are we going to do? We'll be just checking whether our audio and video is fine. If it is good, just say yes. Yes, it's online. Yes. Hello. Hello. Just check it. Perfect. So we can start a session. So tell me, how's everyone? Has been almost a week. We didn't have any class, so finally we are having, and we are going to meet in our Let's Crack J in English session. Hi Dikshant Astukar. Just if I am pronouncing your name incorrectly, just I beg your pardon. I'm really sorry, buddy. It's Dikshant, right? Okay, Dikshant. So today we'll be studying our very first lecture on inverse trigonometric function. Are you in 11th or 12th? No response from Dikshant. So Dikshant, so that's me, Nishant Khanduja. So that's our very first lecture on inverse trigonometric function. And I graduated and post-graduated from IIT Bombay in aerospace engineering. My rank in IIT was 1256. In AIEEE it was 363. I have traded in US and Canadian markets, and it has been almost 8 years I have been teaching IIT JEE aspirants. And I always wanted to teach students, those who are there in their hometowns, in small cities, small villages. There, I can't reach there, but this education can reach there. How? Via Unacademy platform, via Unacademy is India's largest campaign. What's that? Let's Crack J. So I got associated with Let's Crack J with this campaign, and now I'm here teaching you guys. So before we start a class, before we begin, I request you guys to join these two Telegram channel. One is Let's Crack J in English, and another one is what? JE Quest. So please join, because all the updates regarding the lectures, regarding the content, everything is being put up there. So please join these two groups. So when I was talking about Unacademy application, why it is so good that you guys need to be there and learn from here. I'll tell you the reason. First is India's top educators are there. So whenever you feel like, wherever you feel like, you can just access this application and you can just come and start grabbing the knowledge. You can also attend all the live classes here. So it's like an offline classroom experience, what you get in your coaching institutes. Right now, you do not need to go anywhere else. You just be at home and study. You can just be a part of polls conducted by the educators. You can just see the leaderboards also. So when you see the leaderboard, when you see results there, you try to compete with your colleagues, with your fellow students. That yes, I am there to beat you up. So all these good things are there in this application. You get daily practice problem sheets, you get quizzes, you also have weekly test series, you can interact with the educator. So it's like, you can say it is equivalent to an offline classroom experience. Now whenever you open this application, what do you see? It's like every time any of these live classes are always on. So you can just go to any of these live classes and start grabbing the knowledge. That's the best part of this application. So how to install this application, how to get benefited? First, go to either your Play Store or App Store, install an Academy Learning app. Once you install it, then select your goal. What's your goal? You want to crack IIT. So select that and post that. You can just press on subscription button. The moment you press this on subscription button, you get options for 1, 3, 6, 12 and 24 months subscription. if you look for a suggestion, I would say if you are in 11th standard, then go for 2-year subscription. If you are in either in 12th or 13th, then go for this 1-year subscription. Reasons are very simple. See, if you are in 11th, so obviously for preparation for you is what? For 2 years. So you would like to have the access of the application till the examination gets over. So before the examination, let's say you want to have mock tests, you want to discuss some doubts, you want to revise something. So you need to have the application's access. Now let's talk about the pricing. If you just look at the price of this 2 years package, it's very cost effective. Look at the per day wise price. It is 70 rupees per day. Don't you think it's a very nominal price? Yeah, it is. Indeed, it's a very nominal price. And that is for India's top educators. Correct? So 70 rupees per day, it's a very nominal amount, and it's a very nominal amount. So yes, if you accumulate everything, what do you see? For 2 years, you need to pay what? 50,400 rupees. Whereas for 1 year, you need to pay what? 34,650 rupees. Now, this price would only flash if you punch my code NK001. If you don't punch my code, you would see the prices are still higher. So you need to punch this code so that you can see the lesser prices. Now for Iconic, what do you need to pay? You need to pay 90,000 rupees. And for 2 years, you need to pay 90,000. For 1 year, you need to pay 58,500 rupees. So these are the prices you need to pay for Iconic. Now you would say, why Iconic is expensive? What's the reason? The reason is very simple. Because in Iconic, apart from the benefits you get in Plus, you are getting something extra. Now what is that extra? That extra is you are getting guidance. Now guidance is very important in today's era. Someone might be having a good knowledge, but a guidance can make or break it. Yes, indeed. So you will be having your personal mentor. So this personal mentor will be helping you out to strategizing your strategy for the examination. You will be having test analysis report. So this test analysis report would tell you how to improve the time management, where exactly you are losing mark, in which section, how to improve the positive marking, how to improve your examination approach. You will also be having one more extra thing. What is that? Study planner. So this study planner would be customizing the study according to your own need. It would be also reviewing your progress bi-weekly. So in a way, it's like you will always be on the track to your goal. That's there in Iconic. That's the beauty of this. So it's like when the top quality content and the guidance, they merge together, so your best possible result is certain. So if you look for a suggestion, I would say do buy it as soon as possible, because the more time you give for your preparation, the better result you will see. Now one more announcement I would like to make. This is regarding the Unacademy Combat. So Unacademy Combat is happening. The fourth round of Unacademy Combat is happening on 20th of December. So you can enroll for this using my code NK001, and then you guys can come with me, and then we will be preparing for it. Why I'm asking you to punch this code? Because I want my students to really compete, and yes, certainly I'll be getting a credit for that, but yes, I'll be happy that yes, my students are scoring good ranks. Last time, one of my students, Aman Kumar Singh, he scored AIF 35, and I'm very happy with that, and I want at least 10 people should be there in under 100 this time. So that's my target. If you can compete, yes, then certainly go for it. And you can just punch my code NK001. So let's start our session. So first of all, we'll talk about the trigonometric functions. So what are these trigonometric functions? So you have your sin x, you have your cos x, you have your tan x, you have cot x, you have sec x, and you also have cosec x. Now let's talk about their domains and range. See, here x can take any value, right? So real number. Now the range is always sin x varies from -1 to 1. Similarly, Cos x can take any value from real number and it has range from -1 to 1. Let's talk about tan x. Tan x can take any value from range, but it is not defined on the odd multiples of pi by 2, right? Your n belongs to what? Your integer. And range, it is real number, -infinity to infinity. Similarly for cot x, if you talk about, cot x is not defined where you see cos x is becoming 0. Where do you see cos x becoming 0? Yes, on the integer multiple of pi. Yes, pi, 2 pi, 3 pi, absolutely right. So n pi, here n belongs to your integer, correct? And your range, yes, range is still the whole real number. Now let's talk about sec x. Now 1 upon cos x. Now when you see cos x becoming 0, the function will not be defined there, right? So what are these points? Again, integer multiple of pi. So r minus n pi, here n belongs to integer. And your range would be what? Starting from -infinity to -1, union 1 to infinity. Similarly for your cosec x also, range will be the same, only your domain would change. Here we have to remove those points where sin x is becoming 0. And sorry guys, this is becoming 0 at odd multiple. My bad, that's my mistake. Sec x, cos x would become 0 when we have odd multiple of what? Pi by 2. So 2n plus pi by 2. Yes, and here integer multiple of pi, where you see sin is becoming 0, correct? Okay, so now let's talk about, these are the normal function, trigonometric function. Now can you please tell me, we have read inverse trigonometric function. Can we define inverse trigonometric function for these sets, for these domains and range? Tell me. I think we can't. The reason is very simple, because this function is what? This function is many one and onto. So therefore you can't. See, function is like a mirror, right? So see here, for, if let's say this is a function, so for every object you should have an image, true, a unique image. Now tell me one thing, if at all, because right now what is happening here is, for many values you are getting what? One value, correct? Now if I want to define a function from here to here, from B to A, will it be defined? No, because for one element you are having 3 images, and that's not possible. For one object you can have only one image. So to define inverse trigonometric, we have to put restrictions on our domain. Yes, so we have to shrink our domains, then only our inverse trigonometric function would be defined. So now what would happen? So now our domains would change, and then only we'll be able to define. So how do we represent inverse function? So for sine, we represent sine inverse x, cos inverse x. You might ask me, how do we represent them? So for say, if x is equal to cos y, so y will be written as cos inverse x. So that's how we write it. Similarly for sine also, tan also, cot also, that's how we write them. Clear guys? Now you understood how do we represent and how do we get them in equations. Fine. Now let's talk about their graphs, domain and range. Let's talk about them. Okay. If you remember, when I taught you functions, I told you this thing, that whenever we want to draw inverse function, y is equal to f inverse x, how will it look like? It will be like a mirror image. It will be like a mirror image in y is equal to x. So I can say mirror image of y is equal to f of x in y is equal to x. Okay, so we'll be using it and see what happens. So sine inverse x. So here for sine inverse x, as I was talking to you, we have to define inverse trigonometric function. We have to first shrink the domain of what? Shrink the domain of your trigonometric function. Now, first I'll be drawing your sine x curve, where I have shrunk the domain of sine x. Now I'll be drawing sine x from minus pi by 2 to pi by 2, because I see between minus pi by 2 to pi by 2, this sine x curve achieves all the values, whatever values are there in the range. So this is, let's say, minus 1 and this is your 1, correct? Now, as I told you, so this is your sine x normal function. Now if you want to represent what, and if you want to draw what, you want to draw inverse trigonometric function of sine inverse, right? So how would you draw it? As I told you, you have to take the mirror image. Hi WTF Ness, what's up? Okay, so now you want to draw the inverse trigonometric function. So how would you draw it? You have to take the mirror image. So you can just draw the mirror like this. So obviously at minus pi by 2 we would be seeing your y is equal to x line somewhere here. Okay, now let's try drawing the mirror image. So you would be seeing here I'll have pi by 2 minus pi by 2 minus 1 and 1. So see here, it will start from here and it will come like this. So that's how you will be seeing the curve, right? Yes, WDFness, right, Dikshant? Okay, now this is the mirror image concept. Now let's say if you are not good with mirror image, so what is the alternative to draw the inverse trigonometric function? So what you can do is you can just swipe between y and x-axis. Now how? What you can do is, see here on x-axis I wrote pi by 2 minus pi by 2, right, for normal function. Now pi by 2 will be given to the y-axis, same, and 1 minus 1 will come to the x-axis, correct? Now this was there in the positive part, correct? Here again for the positive part here, and this was there in the negative part. I drew it in the negative part, that's it. So you can just swipe x and y axis. Now let's talk about the domain and range for this. So for inverse, the sine inverse x, your domain would be what? Domain would be minus 1 to 1, whereas range will be from minus pi by 2 to pi by 2. Clear, guys? I hope this is clear with everyone. Now let's move ahead. Let's talk about cos inverse x. So now let's see how we are going to shrink the domain for cos x first. So for cos x, we see that cos x achieve all the values between 0 to pi. This is 1, okay, so minus 1, it is started from minus 1 and it gone down and it is still here, okay. So now if I want to draw the inverse function, so what did I tell you? This is your cos x graph. Now for cos inverse x, what did I tell you? I told you whenever you want to draw the inverse function, you just need to swipe x and y axis. See, here we were having what? Minus 1 to y, right? So minus 1 to 1. Now 0 to pi on the y axis, okay? And this is a pi by 2. Let's Let me just change the color so that we can draw it nicely. See, now here we can see it was 1 when it was 0 here. So give me 1 here, okay, then here, and then at pi it was -1. Fine. Like this. So what will be the domain for cos inverse? So they'll just swipe. So here, as you can see, for cos x the domain is from 0 to pi. Now this will become the range. 0 to pi is what? Range. And what is the domain here? Domain is still the same, -1 to 1. Here, let's move to our another function. First, what we'll do, we'll first check 10x. So how I have shrunk the domain of 10x. So 10x, for 10x I have made the domain from -pi/2 to pi/2. Now how does it look like 10x? It looks like this. Okay guys, now if you want to draw its inverse, what do you need to do? You just need to swipe between what? Between your x and y axis. So here on the y axis we'll be writing what? These -pi/2 to pi/2, and infinity will be there now on the x axis. So see, at pi/2 what I can see is that it's going to positive infinity. So here I will be going positive infinity minus. So how will it look like? It will be like this. Like this. This is your tan inverse x curve. Now, if you want to talk about its domain and range, what are these? So for tan inverse x, your domain will be what? You can take any value from -infinity to infinity, and what will be the range? Range will be from -pi/2 to pi/2. So this will be your range. Here. Now let's talk about your cortex graph. So let's see how to shrink the cortex domain. So now cortex will be defined from 0 to pi. And the first quadrant, your cortex is what? Positive. Let's say it will start from here and then it will go till here. Here. Now let's try drawing its inverse. So as I said in the beginning, what you can do, you can just swipe x and y axis. So here 0 to pi was there on the x axis. Now 0 to pi will be there on your y axis. Now it was becoming 0 at pi/2. Okay. Now when y was okay, when x was 0, it is tending to infinity, correct? So when your y will be 0, your this will be tending to infinity. So it will be like this. You can just cross check it. You can just, whenever you feel like, you can just draw the mirror image and see. Okay guys, so that's your cot inverse x. So if you just look at its domain and range, what it is. So for cot inverse x, your domain is what? Your domain is from -infinity to infinity, and your range is what? The range is 0 to pi. Here. I hope this is clear with everyone. Okay, let's move ahead. Let's talk about your sec x graph. So for sec x get, or you can say attains, every value between 0 to pi. But it is certainly not defined at pi by 2, because at pi by 2 your cos x becomes what? 0. Okay, let's try drawing it. So at 0, what is the value of sec x? 1 upon 1, 1. So here 1, and we'll go till up infinity. Now in the second quadrant, your cos x is what? Negative. It will be like this. So now let's say if I want to draw its inverse, or you can say it's a mirror image, that will be what? Your sec inverse x graph, right? How can you draw it? First, let's go for swipe. So 0, and here we'll have pi by 2. Here we'll have pi. Now see, 1 was there at on the y-axis, so 1 here we'll have on the x-axis, and minus 1. Okay, so now check. So when y was 0, so now x was 0, it was 1, and y went till infinity. Now x will go till infinity, so it will be like this. Now from here, when it was pi by 2 at x, now here y was minus infinity, now x will be minus infinity until come till 1, minus 1. That's it. That's how you are going to draw sec inverse x. Now for sec inverse x, if you want to write domain, so as you can see, it will take values from minus infinity to minus 1, union 1 to infinity, and range would be what? Range will be, as you can see, it is between 0 to pi. 0 to pi, but there is a catch. Now what is the catch here? Now when you see the range 0 to pi, 0 to pi, yes, 0 at, yes, close bracket. Why I am taking the close bracket? Because at 0 we get what? 1. 0 to pi minus. Now which value we have to remove? Where it is not defined. Now where exactly it is not defined, as we can see at pi by 2. Here. Now let's talk about, we have spoken about, oh, we forget about cosec also, cosec x. Now for cosec x, what is the graph of cosec x? The domain is what? Minus pi by 2 to pi by 2 for cosec x. It looks like, okay, wait a minute guys. Let me just erase it. Yes. So yes, for cosec x, as we know, sin x becomes 0 where? When it is 0, right? So at 0 it will be going to infinity, and at pi by 2 it will be becoming what? 1. Like this and like this. This is 1 and this is what? Minus 1. Now if you want to draw the inverse function of this graph, so how will you draw it? You just need to swipe it, that's it, nothing else. So see here, now 1 minus 1 was there on the y-axis, right, earlier. Now everything will be on x-axis. Now pi by 2 minus pi by 2, these two things were there on the x-axis. Now they'll go to y-axis. Now check here, at pi by 2 positive, it was at 1. So okay, fine, it will be somewhere around 1. Okay. Now what you need to do is, as you can see, it was going to infinity. It was going to infinity. It was going to infinity, y infinity. Now it will go to x infinity. When your x was becoming 0, now when your y will become 0, and at pi by 2 it was what? 1. So here So this will look like this here. Now for negative, at it was here. Now as you can see, it was going to minus infinity when y, on the y. Now it will go to minus infinity for x, like this here. So this will be your cosec inverse x. Now what will be the domain? Minus infinity to minus 1 union 1 to infinity. Next, let's talk about the range. Range will be obviously minus pi by 2 to pi by 2. But as you can see, it is not defined where at 0. So we have to exclude this point. Clear, guys? I hope this is clear with everyone. Clear? Let's move ahead. Let's talk about the properties now. Now today we will be talking about four or you can say 5 properties in inverse. We will be talking more properties later on, but these are the prime properties. So one is, see, whenever you write sine inverse x, what will be the value? Tell me. Cos inverse x, sec inverse x, cosec inverse x, and then finally what? We have 10 also. 10 inverse x and cot inverse x. Okay, now look at these. So when you look at them, what do you think? The very first thing is, when this is like a composite function, right? This is like a composite function. Now sine inverse will give you value what? It will give you value between minus pi by 2 to pi by 2. Now sine will accept because it will work as an input for sine function. So sine will give you value whatever is relevant to minus pi by 2 to pi by 2. Here, now tell me one thing. Now those values, because as sine inverse is what? 1 function, correct? It's a 1 function. So by default, this sine will also give you the same value. It will become like what? Identity function, right? Same goes for cos as well, sec as well, cosec as well, tan as well, and cot as well. Given the fact that x belongs to respective domains. Domains for the respective functions. What I mean to say is, obviously x will be different for sine inverse, x will be different for cosec inverse x, that we have already spoken about the domains. That's why I have not written it again and again. Okay, so x should belongs to domain. So it should not be like x is 4 here, sine inverse 4. That can't be defined, buddy. That can't happen, correct? Because that is not defined. Sine inverse can't take value 4. The domain, the maximum value what it can take is what? 1. So every value should be what? Lesser than 1, or it should be more than minus 1. So what I mean to say, okay? Now let's move ahead. Let's talk about other property. Now just imagine if it works other way around. Now what is that? What I mean to say is, if I have written like this, sine inverse sine x. Now when I put input here, so sine can take any value of x, because for this domain is defined like a real number, right? So it can take any value. Now when it takes any value, it will give you value, let's say between minus 1 to 1. Obviously sine inverse, for sine inverse it is perfect, correct? For sine inverse it is the perfect value, and then according to between minus 1 to 1 values, it will give you the final answer. Now tell me one thing, if I have written x something like this, can I use this as identity function? Can I cancel it out like this and write x? Tell me. No, that's not possible. I'll tell you how. Why. Just imagine, as I told you, that this sine function can take any value of x. Now just imagine if it is 5. Fine. Sine cancel out and I got 5. But is it possible that can sine inverse give you 5 value? No. the value always needs to be between minus pi by 2 to pi by 2. So that means there is some catch. Now how to grab it? How to just think rightly? How to write the sine inverse sine x? This should be equal to what? This should be always between the range minus pi by 2 to pi by 2. Okay. So how to do that? That's the art. Now how to learn that art, I'll tell you. So the very first thing what you need to do is, whenever you are looking this thing x, if obviously if this x is between minus pi by 2 and pi by 2, obviously we do not need to change because that is valid, that is true. But now if it is not, then what? And for that, what we need to do is, the very first thing is we need to break this angle. We need to break this angle or you can say rewrite this angle. We need to rewrite this angle in such a manner that this sin x should not change its value. It's not about for sin x, I'm telling you for everyone. So this is the rule, the way we need to rewrite this. This rule is applicable for every function, like sin inverse sin x, cos inverse cos x, sec inverse sec x, where inverse function is the first function. When you come from the left, your inverse function is the first. Sin inverse sin x, like this. Okay. So this value should not change. The very first thing is this value should not change. And we have to break this angle in such a manner that should not value change, and the angle should lie between the range. Now you would say, sir, two things we have to, it's like two conditions are there. But don't worry, I'll help you out. So I'll help you out with different functions, how to break them. I'll give you some strategy. Now first strategy is that this angle, the way we need to rewrite this angle, we need to rewrite it in such a manner that the sin x value should not change. Okay. And the range should be in between what? This angle should be in between. The new angle should be between the range. Correct? That's what I said. Now, how do we write this x? So we write this x like this: n pi plus minus 1 raised to n x. So that's how we rewrite this x. Now you would say, sir, now can you please give us an example? Fine, I'll give you an example. Imagine your x is, for example, what I'll do is I'll just change the color so that you guys stay attentive. So imagine your x is, let's say, let's say 9 pi by 4. Let's say, just imagine 9 pi by 4. Okay. Now, obviously, when you look at 9 pi by 4, you can't do this. Sin inverse cancel out and x is equal to 9 pi by 4. It would just void the sin inverse function altogether. So now, thing is how to break this 9 pi by 4. So if you look at this n pi, what it says, you have to break the angle in such a manner. First, what you need to do is you need to figure out where exactly, in which quadrant this n pi by 4 would lie. Obviously, from here to here, 2 pi, then again in first quadrant, correct? 2 pi plus something. Am I correct? Right? So how will you write? So you will be writing this in second quadrant, in what? First quadrant only. So how can we write? So as it is clearly for us, as we clearly see, it is there in the second quadrant. So how we will be writing x? Rewriting x is 2 pi, since I wrote 2 here, right? So 2, so minus 1 raised to 2, so it will become 1 plus n pi by 4 only. But now tell me one thing, don't you think this angle will be going beyond our limit, right? It is becoming what? It is becoming what? It is becoming more than pi by, it is becoming what? More than pi by 2, correct? So that means we can't take it. Now think about other case. Now I move anti-clockwise. Now can I move clockwise also? Yes, I can move clockwise also. Let's move clockwise. When we try to move clockwise, what do I see? Minus 2 pi, fine. Minus 2 pi plus, again I'll have 1 here, then 9 pi by 4. 9 pi by 4, correct? Now tell me one thing. This is what? If you try to check this, you replace x by, your x is what here? 9 pi, right? 9 pi by 4. Now I'm saying it, check this, sine minus 2 pi minus, so plus 9 pi by 4. Check this value. See, if you want to take minus common, take minus common, minus will be out. So now this is what? 2 pi minus theta. So you would see as if this value is in the fourth quadrant. In fourth quadrant your sine is negative, and this will become what? Sine of 9 pi by 4 only, correct? So your sine x value has not changed, so it is valid. Second, look at this. Second is, look at this value, calculate this minus 2 pi plus 9 pi by 4, calculate this. Try calculating this. You would see you are getting what? Pi by 4. And this pi by 4 is what? It is this minus 2 pi plus 9 pi by 4 is what? This is between the range only, between minus pi by 2 to pi by 2, correct? Yes. So you can rewrite this. If you want to write this, how will you write this? 9 pi by 4, this sine inverse sine of 9 pi by 4. This value will be equal to what? This value will be equal to sine inverse sine of minus 2 pi plus 9 pi by 4, and this will be equal to what? Minus 2 pi plus 9 pi by 4, and if you solve it, what do you get? Pi by 4. And yes, indeed, it's in the range. And you can check the value also, you can cross check it. Check sine n pi by 4. It's in the first quadrant, the value will be what? 1 by root 2. Sine inverse 1 by root 2 will be what? Pi by 4, and it is, you're getting the same value. So that's how you can do it. Now I'll give you the certain relation, how you can do it. See, when it is all about sine function, so we have to use this rule. N pi plus minus 1 raised to nx, okay? When it is about, let's say, cos inverse cos x, when about this cos, so here what we have to look for? We have to always look for this x can be written as 2n pi plus minus x. Basically, it's like I am checking in first and fourth quadrant. I'm trying to break this angle or rewrite this angle in such a manner that it is always close to even multiple of pi. Okay, and make sure that yes, this thing, whenever you get new thing, this should always be between 0 to pi. Make sure this. Okay, for tan inverse 10x, for tan function, remember it should be what? N pi plus x. It's like first and third quadrant. What? First and third quadrant. Okay, and this should be what? This, the value, when you rewrite this should be always between minus pi by 2 to pi by 2. Am I clear, guys? I hope this is clear with everyone. If you have any doubt, whosoever is online, because right now I can't see who is online, but if anyone is online, yes, hi. Okay, is it clear, guys? Now, and yes, similarly for cot inverse cot x also, and similarly for your sec inverse sec x also, same. We'll be writing 2n pi plus minus x, and this should what? This should belongs to what? Your 0 to pi, but just make sure, since your sec x function is not defined where, it is not defined on the odd multiples of pi by 2, so yes, obviously you can't take those values, so I'm just extracting those values. Same goes for cos x inverse cosec x also, minus pi by 2 to minus pi by 2, 1 upon this, correct? You have to exclude this odd multiple of this n pi. Remember this. How will you be writing it? N pi plus. It's like this. This should belongs to this, but it can't be a multiple of pi. Here n is what? Integer. Here guys, here also n is what? Integer. Everywhere your n is integer. Remember this. Here guys. So this is very good property. Please do remember it. Now let's talk about another properties like sine inverse minus x. This will be equal to what? Minus sine inverse x. Now if you want to know how we did it, the very simple logic is, you can assume sine inverse minus x as, let's say, y. So this what? This will be what? Sine y is what? Minus x. X will be what? Minus sine y. I can take minus sign inside, so it will be what? X is equal to sine of minus y. Now take the inverse, so I'll be having what? Sine inverse x is equal to what? Minus of sine y. What is yr? Y was, this is what we assumed, right? So that's how we can say this. Same thing goes for your tan also, tan inverse x. Same goes for your cosec. But for cos inverse x, there is a change. You will be writing it like minus pi minus cos inverse x. Now how can you do it? It's very easy. The way we did this, similarly you can do it. It just, here we took minus sign inside. You have to assume, not assume, obviously you, for negative value of cos you find when cos is there in the second quadrant. Sec inverse x minus x, pi minus sec inverse x. Even cot inverse minus x is equal to what? Pi minus cot inverse x. Those who can't imagine it, I'll be helping you guys out. See, let's say cos inverse minus x is what? Y. Just give me a moment, I'll change the color. Okay. So let's say your cos y is what? Minus of x. Now if I take minus here, I'll make it positive. So this can be further written as what? Cos of pi minus y, right? Second quadrant, x. Now I can take what? Cos inverse x is what? Pi minus y. Now cos inverse is here. This is pi. I will be writing y here. Y is equal to what? Pi minus cos inverse x. Now what was y? Initially we assumed cos inverse minus x as y. So cos inverse minus x is equal to what? Pi minus cos inverse x. That's how you can easily prove sec inverse minus x, cot inverse minus x also. Okay, so this is also one of the good properties. Remember this. Now we will be talking about these properties also. Sin inverse 1 by x. So this can be written as cosec inverse x peacefully. Now tell me for what values? When x belongs to what? Minus infinity to minus 1 union 1 to infinity. Similarly for sec also you can write it down. Sec inverse 1 by x, or I'll do what? Sec x. I'll write it this way. Let's say sec inverse cos inverse 1 by x, given x belongs to minus infinity to minus 1 union 1 to infinity. Here. Now, what about tan inverse? See, there is a catch in tan inverse. Tan inverse 1 by x, where x belongs to what? All the real numbers. Okay. So now, what is the catch here? Tell me. Can anyone guess the catch here? Obviously not 0, because 1 upon 0, that's not possible. So obviously you can't take 0. So what is the catch here? The catch here is, see, if you will try to write it like this, cot inverse x, there's a problem, because see, if x is negative, so by default tan inverse will give you value from minus pi by 2 to 0, correct? Fourth quadrant. But when you will be writing cot inverse minus of x, something like negative value of x, so this cot inverse will give you value in the second quadrant, pi by 2 to pi. So things would go wrong. Something which is in fourth quadrant value can't be equal to second quadrant value. You have to do something. So to compensate that, we add minus pi in cot inverse if x is less than 0. If x is greater than 0, then there is no issue. Then there is no problem. Now, if you ask me to prove it, it's very easy to prove. You can take, again, tan inverse 1 upon x, you can take y, and then you can start proving it. It's very easy. Okay, guys? So these are the properties, very important properties, and yes, I'll tell you three properties also. So one is your cot inverse x, tan inverse x is equal to pi by 2. Similarly, your sin inverse x plus cos inverse x equal to pi by 2. Knowing the fact that x belongs to the range, to the domain. Now what is the domain here? Minus 1 to the 1, and here it is real number. Same goes for sec inverse and cosec inverse also. Okay, here guys? Fine. Let's move ahead. Now let's solve a few questions. We have started a lot of theory. Now yes, we feel like solving questions. Now see, what is the question? It says sin inverse bracket cos inverse cos x plus, so it's there in the bracket only, sin inverse sin x. Till here it's there in the cos x. So it is inside cos x. So how to solve this? And they have given what? Where x belongs to pi by 2 to pi. So now it's very easy. See, can you now tell me one thing? Can you cancel sin inverse and directly write x here? No, you can't. Why? Because sin inverse can't give you value between pi by 2 to pi. It is bound to give you value from minus pi by 2 to pi by 2. That's what I made you understand lately, right? So what do we need to do? We need to break this angle in such a manner that sin x value, the sin x remains untouched, as in uska value should be the same first. Second is your angle should be what? It should lie between minus pi by 2 to pi by 2. So now how will we do it? So as we can see, this angle is lying in the second quadrant. So we'll go till pi. Okay, we move till pi. Fine. Pi minus x, because n pi. So n is what here? 1. So pi minus x. So try writing like this: sin pi minus x. Yes, value is unchanged because we will be getting sin x only. So it is unchanged. Take second tick. Let's check for the value. So pi minus x. X is varying from pi by 2 to pi. So pi by 2, so we'll be having maximum value pi by 2, or minimum value we'll be having what? 0. Yes, it's in the range, correct? So it's correct. Pi minus x we can write. So let's write sine inverse sine of pi minus x. Cool. So I'll be writing it like pi minus x. Fine. Now this is cos. Yes, it's there in the range 0 to pi. So we can cancel it out and we can easily write x. So x will cancel out. So what do we have now? We have sine inverse cos of pi. Cos of pi is what? Cos of pi is minus 1. Sine inverse minus 1. When do we get this value? Minus pi by 2. So what is the answer? D. That's it. We're done with the question. Easy question, right? Correct, I know. Let's go to this question. The principal value. Now we have to find the principal value. So principal value means what? So basically the value of this sine inverse function between the range, this range. Now see, this is sine inverse sine 10. Look at this 10. Where exactly this 10 would lie? So 3 pi, close to 3 pi, 3 into 3.14, right? So 3 pi will be what? Till 2 pi and third quadrant, right? So we'll have to move till third quadrant. So closest to third quadrant. So let's say I write 3 pi. N pi is like 3, let's say 3 pi. So minus 1 and x, 10. Now just check this value. If you check the overall value of this 3 pi minus 10, so this will be what? 3 into 3.14, somewhere around 9.4 to minus 10. So yes, it is between minus pi by 2 to pi by 2. It is a negative value, but it is between, right? So, and if we try to write sine like this, second quadrant, it's like 3 pi minus theta, second quadrant. So in second quadrant, sine doesn't change its sign and it remains as it is, right? So yes, both the constraints are done. Sine 10, yes. So we can assume this value. So what we can write? We can write 3 pi minus 10 sine and then sine inverse. Now sine inverse, this can be cancelled out. So finally what will we get? 3 pi minus 10. C is the correct answer. Done. Let's check this. Cos inverse cos 5 pi by 4. Now see, this 5 pi by 4 is where? This is there in the, as you can see, it is beyond pi, 0 to pi. It is not between 0 to pi, it is beyond pi. So what are we going to do? We have to break it. Now how can we break it? I told you for cos, it is like 2n pi plus minus x, correct? So we have to rewrite x in such a manner like this. And this is what? 5 pi by 4. So this would be closer to what? This would be closer to, certainly this would be closer to your 2 pi. So write it like this, 2 pi. Now what would you prefer? Writing it like 5 pi by 4 or minus pi by 4? So I would prefer this one. Why? Because this is in the range. This is between what? 0 to pi, correct? This is not. So I would prefer this. Now check whether we get the same value or not. 2 pi minus 5 pi by 4. 2 pi minus theta, fourth quadrant cos is positive. So we'll get the same thing. Yes, same thing. Now we can rewrite our angle. So cos inverse cos of 2 pi 5 pi by 4. So this will cancel out. So what it is? 2 pi minus 5 pi by 4. 3 pi by 4 is the answer. B. That's it. Here through. Now let's solve this question. This seems to be, it's again an easy question. It's just four independent questions are there. We have to just add them. Okay. Now see what it is. Sine of 22 by 7. It's like again pi into pi. Okay, so don't you think it will be closer to 3 pi? If you move, so it's like 3 pi, closer to 3 pi, don't you think? Yes, because this is what? This is pi only. 22 by 7 is what? It's like a pi, right? So close to 3 pi. So if I want to write it, how will I write it? So n pi plus minus 1 x, right? That's how we write sine thing. So 3 pi minus 1, so 22 pi by 7. Now check the range. It is between what? 27 minus pi by 7. So obviously minus pi by 7 is between your minus pi by 2 to pi by 2. So it's in the range. So tick for that. Let's check the sign value. So second quadrant sign is always positive. Yes. From sign also it's perfect. So how will I write this? 3 pi minus 22 pi by 7. Clear? Now let's check for this. This is 5 pi by 3 going beyond pi. So how will I write this, buddy? So 2 pi. I have two options, 2 pi plus 5 pi by 3. Obviously this I can't take. The other option, 2 pi minus 5 pi by 3. Yes, it is between the range. Why? Because it is pi by 3. Correct. In the fourth quadrant, cos will not change value. So yes, the value for this will be what? 2 pi minus 5 pi by 3. Now let's go for this. It is beyond pi by 2. It is beyond pi by 2. It is going in the second quadrant. For 10x, how do we write? For 10x, I told you guys. For 10 inverse, 10, 5 pi by 7. How do we write? We write it like, we write x as n pi plus x. So since it is going in what? Second quadrant. So what do we prefer? I would prefer writing it like, instead of going anti-clockwise, let's go clockwise. Okay, so minus pi plus 5 pi by 7. So see, it is what? Minus 7 minus, so it will be what? Minus 2 pi by 7. So minus 2 pi by 7, yes, it is within the range. Minus pi by 2 to pi by 2, yes, it is within the range. Let's check it for whether function changes its value or not. Tan of minus pi plus 2 pi or 5 pi by 7. We can change, we can take minus n common. So this will be pi minus something. So this is pi minus something. So second quadrant 10 is negative. So negative will become positive. So tan of 5 pi by 7. Yes. Tan is also not changing its value. Perfect. So how can we write it? We can write it like minus pi plus 5 pi by 7. Now let's, last one, sine inverse cos 2. How can we do it? Cos 2. Okay, so this cos 2 can be written as sine of pi by 2 minus 2. Can I cancel sine inverse? Let me just check. Pi by 2 would give you value what? 1.57 minus 2. Yes, it is between the range minus pi by 2 to pi by 2. So we can rewrite it. Positive pi by 2 minus pi minus 2. So let's solve this. So 5 pi and this minus pi. So we'll have 4 pi and this 9 pi by 2. Okay, 9 pi by 2 clear. Now this is, if you try solving this, so this is minus of 17 pi by 7 minus 5 pi by 3 and then minus 2. Let's try solving these. So I'll be taking LCM as 42. So this is what? This is 21 into 9. So 180 and 189 minus 6 into 17, 85 and 102 minus 3, so 14, this is what? 14 into 5, 70 pi minus 2. So this is what? What do we get? 17 pi. 17 pi by 42 minus 2. So this should be the answer. Do we have any option like this? Yes, A is the correct answer. We are through. Like, very easy question. See, the moment, if you just realize it has been almost an hour, we were studying about the theory. The moment we are solving questions, it's like really fast, quickly we are solving the questions. And that's what happens when your theory is strong. Now let's solve this question. Tell me, how would you solve this? Any idea? Any guesses? Tan of this. So this will give you some angle, and then we have to calculate half of tan of half of that angle. How can you calculate? Any idea? So I'll tell you. So whenever you get absurd values where it is difficult for you to find the angle, I would say assume that as some angle. Then start solving it. Cos of theta is equal to what? Root of 5 by 3. See, this is kind of, you can say, the information we have. Now what do we need to find? We need to find tan of, this is what we assume, theta. So theta by 2. Now think, how can we find the value of tan theta by 2 when we know cos theta? Think that ways. Yes, we can use what? The angle formula. We can break the angle. Yes, we do remember the formula of cos theta in tan theta by 2. What is that? 1 minus tan square theta by 2. 1 plus tan square theta by 2 is equal to what? Root 5 by 3. Let's start solving it. So 3 minus 3 tan square theta by 2 is equal to what? Root 5 plus root 5 tan square theta by 2. So what it is? 3 minus root 5 upon 3 plus root 5 is equal to what? Tan square theta by 2. But do we have any option like this? No, we don't. So let's do one thing. Let's rationalize it. How can we rationalize it? We have to multiply with denominators conjugate. So when we do that, so what do we have? We have this square and 9 minus 5, 4. Now what we can do? We can take the square root of both the sides. Take. So what do we get? This by 2. This is tan theta by 2. Do we have any option like this? Yes, we do have. Mark this answer. That's it. You're through. Okay, tell me one thing. Why didn't I take? Now tell me one thing. This is a very genuine question. If this thing is what? If this thing is square, I could have got positive and negative values, right? Why did I mark only the positive value? Why didn't I talk about this negative value? Tell me. Any idea? I'll tell you the reason. See, when you see this minus 3 plus root 5 by 2 is equal to tan theta by 2. What do you think? It seems like as if theta is what? Theta is lesser than 0, correct? But now look at here. Cos inverse root of 5 by 3. So it's a positive thing, right? Positive thing. So I'll be getting what? An angle which is between 0 to pi by 2. Am I correct? 0 to pi by 2. So half of that angle will give you what? Half of that angle will also be in first quadrant. When the angle will be in first quadrant, so tan of theta by 2 will be what? That will also be positive. If this will be positive, so I will be getting positive value. Not 5 minus 3 root 5 minus 3 by 2. Not this. This is not possible. Why? Because of the angle. Okay. This is the assumption we have to always look for. If you just look at this, what is this? This theta is, obviously it is very clear that it is between 0 to pi by 2. It is clear. Okay guys, shall we move ahead? Fine, let's move ahead. Okay, this is the last question of the day. Now tell me, how will you solve it? So it is very evident that we have to write this equal to something so that means we have to form this as tan. So how can we form this inside thing as tan so that we can easily cancel out? So cos x can be written as cos inverse x by 2 minus sin inverse x by 2, and this sin 1 plus sin x can be written as sin x by 2 cos x by 2 whole square. Now people would say, how sir? I wrote one as sin x square x by 2 cos square x by 2. Then I made what? This sin x as twice of sin x by 2 to cos of x by 2. So that's how I wrote it like this. Okay. Now it is like what? Sin x plus cos x by 2's whole square. Now if I try to just break it, what do I see? I see this will look like what? Cos x by 2 minus sin of x by 2 upon, I used a square minus b square formula. Now what will I do is, I'll be dividing by what? cos x by 2. When I do that, what do I get? Tan of x by 2, 1 plus tan x by 2. Now what will be this? This will be like what? Tan of pi by 4 minus x by 2. So let's write it here. Tan inverse tan of pi by 4 minus x by 2. So now the thing is, if I cancel this out, I have to be very sure. I have to be very sure that this thing, because if you just look at every single expression, in every single expression, this is what? This is equal to pi by 4 minus x by 2. But when can I write it? I can only write it when this thing, this inside thing is what? This inside thing will always be between what? Minus pi by 2 to pi by 2. Then only I can write. So if that is the case, then use it to find out the value of x. What I can do is I can subtract pi by 4 from all these three sides. So I'll be getting what? 3 pi by 4, and this is what? Minus x by 2, and from this here I'll be getting pi by 4. So what I've done is 2 pi by 4 minus 2 pi by 4 and minus pi by 4. So that's how I wrote it. Now I can just multiply with minus. The moment I multiply with minus, what do I see? I see 3 pi by 4. Inequality sign would change, buddy, like this. Now let's multiply with 2. So this will become 2, this would disappear, and this will be like this. So x should belongs to minus pi by 2 to 3 pi by 2. Check. Minus pi by 2 to 3 pi by 2. A is correct option. That's it. We are through. So that's how we can solve the questions. Very easy questions. So you can also solve it. So don't worry guys, we are still halfway through. So in the next session, we'll be covering more concepts, more questions, and post that we'll be solving previous year questions also. So till then, just be with me and keep coming to my classes. But before I leave, I would like to make a note. So tonight around 8 o'clock, so 8 past 4 p.m, I'm going to have one session on Unacademy application. So you guys can come there, and this is based on what? This will be covering what? Unacademy application. So this will be talking about straight lines. So we'll be solving questions on straight lines. And this is mainly for people those who are targeting mains 2021. People those who are targeting mains 2021, they can come tonight and they can attend my class. Okay. One more thing, this class is free of cost. Free of cost. Now, when can you make it free of cost? Install the application. When you install it, when you do all the sign up process, then just go for my profile. Now, how can you find my profile? You can just find my profile in the description, or if not, then you can search for the Educator Nishant Khanduja. Nishant Khanduja, Khanduja. That's what you need to punch. When you find it, you can just follow my profile and you can just access the videos. When you punch the video would say, sir, provide me a code. Then only you can just access this video. So then you need to punch this code NK001. NK001. It is not O. This is 0. What? 0. So you punch this code NK001, then you'll be able to access the video and you can enjoy my class. Come there. We'll be solving many questions. So it will be a good interaction. It will be a good way to learn. So you guys can come there. And tomorrow on JEE-Quest channel at 11 a.m. I am coming up with one short revision for probability. So you guys can come and in one day, in a few hours, we can finish this off easily. Okay, so come there. So we'll be learning more tomorrow. And if you have liked the video, I would request you to like it, share it with your friends so that they can also learn and you guys can have a good discussion. When we have good discussion, we learn a lot. And you can subscribe the channel, you can hit the bell icon button so that you will get notified. You'll get notification in the future also whenever I come online. And if you have planned to join Unacademy Plus and Iconic, then you can just use my code NK001 because you will be getting what? You'll be getting 10% off. Correct, guys? So we'll be seeing you on Unacademy Plus or Iconic. There we'll be solving more questions. See, you have just seen the trailer. The movie is still there on Unacademy application. So I would request you guys to come there and watch the entire movie. You can attend my entire course there. Okay, guys? So take care. Bye-bye. Till then, we'll be seeing you tomorrow again at the same time. Bye-bye. Take care.